My name is Ignacio Blanquer. I'm working in the Technical University of Valencia, and I am the technical coordinator of the Central Hub in the European Cancer Imaging Infrastructure. What I am going to present today is the achievements that we have done towards having a secure processing environment. Secure processing environment is a key element for building secure analytic platforms in the future. So let me first explain that this will be a presentation that will have an important part of ICT information. So it is not exactly targeted for standard radiologists, but it's more for data scientists that want to develop IA models, to analyze data, or develop their own tools there. So in a nutshell, a secure processing environment, according to the Data Governance Act, is an environment, physical or virtual, in which the data can be securely accessed, processed, and analyzed, and the data holders that provide this data have the security, that have the certainty that the data is not downloaded by people that are not authorized to, and it is only accessed by people that have the specific permission. You can check more details in the links in the presentation for having more information about how the Data Governance Act defines the secure processing environments. Moreover, we are now on the building of the European Health Data Space. The European Health Data Space was approved on March of 2024, but it will be presented officially in Brussels on March 18 this year. It will be of a compulsory, mandatory commitment by all the countries, and it will regulate a way to access massive amount of data from the health systems in the European countries. Especially, one key element is the secure processing environment, because the data that will be gathered from the data holders in the European Health Data Space will only be accessible through secure processing environments. The European Health Data Space defines 6 measures that have to be considered for being entitled as a secure processing environment. Basically, these measures define how the permission should be given to the users, how the users will have specific roles to allow them to modify, upload, or process the data, that the system will make the state-of-the-art measures to guarantee that it has not be the privacy is not put in danger. So they will have measures to ensure that the confidentiality is preserved, and will provide access only to the specific part of the data that is authorized by the data permit that the user will bring. Additionally, it will be also very important to keep auditable logs of any action performed by the user, as well as provide any evidence for the auditing process that will take place in the future. So in EUCAIM, we are trying to address all these regulations, all these requirements, by providing access to only authorized users that have registered to a virtual organization in the life science authentication and authorization infrastructure, giving the permissions through projects and very detailed access control list in which we can define which datasets, which studies are available for each user. So having a very fine-grained data access permission. The uploading of the data is also restricted to a specific users that have a specific right, and therefore we can guarantee that the data that is deposited in the platform and made available fulfills the criteria of quality of the platform. We provide a virtual environment in which the user can explore the data without the capacity of downloading the data, and can even train models using high-end computing facilities. All the actions performed by the user are properly registered on a blockchain, so there is a guarantee of non-repudiation, so a user cannot deny that has accessed the data in a specific time frame. For this, we will make a short demo trying to address this, to show these capabilities using our platform in EUCAIM. So I will go to the platform as says in this demonstration, we'll log in with the proper credentials, explore the data, make an instance of a virtual research environment, and make some analysis of the existing data that we have in this permission. So let's start with the access to the dashboard. The EUCAIM dashboard, let me first log out to see you how you see in the public access, the anonymous access, is the place in which all the different applications and all the different services that we have in EUCAIM are properly indexed and linked. So in this part, you can see information on how to become a user, become a software provider, data holder, or a stakeholder. I will start considering that I have access granted for one data set, and I will concentrate on this part. The part of all the process of exploring EUCAIM, exploring the part of the data sets available, and requesting access will be shown on a different video demonstration. So I will log with my own credentials. I have already logged in through my institutional credential. This is also very convenient. First time to request a user account, you can do it through the instruction that we have in the Become a User, or link into the same point as the login. And then along with the information, I have the list of the data sets to which I have access, approved, or those that are under evaluation. In this case, I will use one of the data sets that is called Colon Cancer Championship Phase version 4, that comprise some information related of medical imaging on colon cancer, and has been used for a massive open challenge in which at the end 22 selected participants work in a competitive manner to develop the best AI model to address one specific clinical use case. So if I go to this data set, I am forwarded to the page in EUCAIM in which you can see the metadata associated to this case. So along with all the information that I can explore, I have a specific link that is imaging data access. So I will go to this, and I will be forwarded to the page in which the virtual environment can be created. So I have managed to go to one to the other because I use these credentials, which are the same in all the different elements. So at this point, I have my user at any point authenticated. I will not be able to do this if I am not properly logged in, if I don't have the access permit provided by the access committee of EUCAIM. So let's go and instantiate one virtual research environment there. For that, I can go to Actions and use the app's dashboard. In this case, what appears to me is a collection of applications for data scientists to process and analyze the data on this data set. So again, data set cannot be downloaded. I have to process them in situ in our platform. This is the way to guarantee the traceability and to guarantee the sovereignty of the data holders. So let's instantiate a session with Jupyter PyTorch. This will provide me tools for AI model creation and other processing tools. So I will give a name, test ECR colon, for example, and I will deploy the instance. Some technological explanation here. What is happening here? Basically, we have Kubernetes, which is a technology that is used nowadays to manage large-scale deployments of applications, and creates a virtual environment in one of the nodes through a pod system, right? So a pod instance. This pod instance runs in this system and can be accessed through a proxy. This means that I cannot use my own browser. I have to use the browser of the environment to access the data, to guarantee that, or to reduce the risks of data leakage on privacy extraction, privacy data extraction. This is another condition of the secure processing environment according to the HDS. So then I have the link for the list of the different environments that I can have. So if I go here, this is the one that I have just created, and I can go and log in to the system. So as you see, this is like a virtual machine, like an environment, a graphical environment, like the one that you may have in your own computer, but it's running, this desktop is running on our premises, in this case in Valencia. This is, again, important to understand how the data is accessed. However, I mean, it works like a normal system. So I have an Explorer, I have data sets, I have the data that I requested available here, as you can see, and in the system. It's important to say that the data is not replicated. What I have is a read-only view of this data. This is efficient because it doesn't create again and again new copies of the data. And also it gives us more control about how the data is being used. Also, we provide some layers so the data can be annotated. It's publicly annotated with a DOI, a document object identifier, so it can be referenced as if it were a publication. So let's go very briefly to a processing environment. For this purpose, we have set up a Jupyter. Jupyter is a very convenient environment for running applications as well as having some data aside, right? So in this persistent home, I have prepared a persistent home is the area that the user has in this environment that can be, that remains stable and remains persistent along different instances of the time. So you may process one data set and then process another one with another environment, and you keep the data on the persistent home there. So I have created one notebook in which you have the explanation, the code, and the result in the same document, and is, I would say, quite easy to follow if you have the skills of data scientists and you have some knowledge on Python in this case. So let's execute very briefly, one by one, and then let me explain a bit what we are doing. So first part only shows how to access the data. The data is available as a file system. It means that any tool that works with data that is on your computer on a file system, it will work there, right? So in this sense, we are simply showing some snips of code, right? So you can check how to, or you can base for accessing files or extracting some information about the files. So this is to get the folder where the data sets are located, and this snippet of code is just to have the list of studies that are studies that are available for this user. To facilitate the development of AI tools, we also provide a file that is called index.json that has the list of all the individual studies. So in this way, if you want to create a model, you can follow this list to know where the data is located and skip the other parts the other files that will not be relevant for you. And you can tailor this file to those files that are specific to your analysis. I will show an example later on. So let me just briefly go there. So this example is available to all the people registered in the platform. And I can simply go up to the point that I even display one of the images in the Jupyter Notebook. That's, again, a very convenient tool because I combine the code with the results of the code and also with some explanation, so it can be useful for training and useful for development. It can be like an executable paper that you may code, right? So I can also show you how to get the all the parts related to the DICOM tags. So, but let's do something more fancy. So imagine that you have already your Python script that make a processing on data, right? That you want to run it there. And this processing script takes hours, minutes, whatever, takes long to execute. This is something that you will not wait until it has completed. So what will be the best approach to run this on the platform, right? Because this will be, for example, the case of training an AI model. So for that, the platform provides a system to submit long term long-running jobs, which is called Jobman. Jobman is a launcher of jobs that will run on the background, will run, and you can switch off your computer and go back later on to see how is the progress, and will deposit the output on a specific folder. So Jobman works quite similar to, combines well with Docker containers or any type of containers, and also with batch queues. So the images that I can use for running my job can be retrieved like this. So in this, you can see that there are images that are prepared for working with MRI harmonization, for privacy preservation. They have a specific tool for that. They have Python environments with PyTorch and TensorFlow, and also a basic Ubuntu Python if you want to run something that doesn't have a specific GPU restriction or whatever. So with all the collection of tools that we have, we will run a very simple, but I would say that takes several minutes, job that analyzes all the series of the different 700 studies that are on this data set and identifies which one of them correspond to a sagittal view. That will be, for example, the case if you want to train a model with sagittal views. There's a lot of information, and you will only need those that are related to sagittal views. So this code has been already implemented in a Python application, and I want to run it on the platform. Right? For this, I will use this process. So I will run the application on the background, and I will take the result later on. I can show you the way of submitting. So job and submit will create this job, will execute this on the background, and then I can see the status of the job, right? So if I go there, let me scroll a bit, I can see the list of the jobs that are executed. And you can see that the one that we have just created is on the running status. So it is being executed right now. As it takes several minutes, I already have prepared another one that ran and completed successfully. And I can show you how is the output of this case. So I will take the one that is this one, if I recall correctly. Yes, the one DFT. Just putting the identifier, and I can get the result. If I click on this, I will get the output of this job, and the output of this job has been that it has identified 1777 series that are X traverse, 404 that are Y coronal, 2,627 series that are sagittal views, and 0 undefined. So it has created an output file at this point in which has the links to all the files that correspond to this view, which will be very useful. So this was the presentation of the environment. Just to conclude, saying that data cannot be downloaded, so we provide a maximum state-of-the-art technologies to guarantee the preservation of the privacy of the data. We do not allow running anything, any image that is not audited, and we have a catalog of audited applications. If there's a new application, we have to we can incorporate it by analyzing it before. And finally, just to show you the part related to the logging and monitoring, we register in the platform all the actions performed to this data set. So in the historical view, this access that we have just done, it will be registered in one of the pages of this blockchain. So in the future, if some action has been considered, it was on the other direction. It will be properly documented, so it can be audited, and any action, any lawful action can be traced there. So thank you for the attention, and stay tuned to our rest of the videos.